The 2 meter long, 15 kilogram beam is hinged beam is hinged at its left end. It is falling, i.e. rotating, clockwise under the influence of gravity. And the figure shows its position at 3 different times. 1, 2, and okay, seems reasonable. For the steps inside, blah, blah, blah. Okay, what is the gravitational torque on the beam about axis through the hinged end when the beam is at the upper position? Okay, so draw a picture real quick. Oh, that is going to be force gravity, which is, looks like we're going to do the top position, the middle position, and the lower position. So we're just basically going to do them all. So the idea here is torque equals R cross F, where R is the radius from the hinge. So that's going to be R. And F, the force, is going to be force gravity going down. So torque is R cross F. A cross product is a measure of how perpendicular two vectors are. So we can decompose R into R. I'm going to call this R perpendicular. I'm going to call this R parallel. So you can see this written in different ways. So it would be R perpendicular F, which is the same as RF perpendicular, which you'll also see written as RF sine of theta, where theta is the angle between the two vectors. So if two vectors are perpendicular, the angle is 90, sine of 90 is 1. Therefore, the cross product of two perpendicular vectors is just the magnitude of the two vectors multiplied by each other. I know, sounds complicated, not too bad. So I did say R sine theta here. That theta is different than that theta here. So this theta is the measurement of the angle from the horizontal. This theta is specifically the angle between the two vectors. In this case, this would be R going this way and force gravity going straight down. So it's easier to think of it as the perpendicular portion of R to F. So we're going to look at just this portion of the R right here. And we're going to draw the force of gravity coming from the center of mass, which is going to be the center of the beam. Lots of talking for the first part. We're going to do a triangle like this. So this is going to be R, this is going to be R perpendicular, R parallel, 20 degrees. We'll do SOHCAHTOA. To find R perpendicular, we're going to use cosine theta. So cosine theta equals adjacent over hypotenuse, which is R perpendicular over R, the total R. Therefore, the magnitude of R perpendicular is going to be R cosine theta, where this theta is actually this angle right here. And so we're going to use that idea. So torque equals R cosine theta times force times gravity, where R is going to equal L over 2, because we're going to use the center of mass of the beam. So rewriting this one more time, torque equals L over 2 cosine theta times, and then I'm going to write force of gravity is going to be mass times gravity. So this is going to be L, which is 2, convenient, 2 over 2 times mass, which I think was 15 times gravity, which I'm going to call 9.8, times cosine of, the first one is going to be 20 degrees. 20 degrees. So doing some math, that's 2 over 2 becomes 1. So the first one is going to be 15. Move this down so we can actually see it. 9.8 cosine of 20 degrees. Grab the calculator. On, clear. Make sure we're in degrees. Nope, we're in radians. Switch that over. So 15 times 9.8 times cosine 20 degrees. We get 138. So the first one, 138 Newton meters. For the second one, where it's horizontal, the angle is going to be 0 degrees. So exact same problem, except now we're going to plug in 0. Plug in 0 there. We get 15 times 9.8 times cosine of 0, which is just going to be 147. So cosine of 0 is 1. So I really didn't have to do that, but I did anyway. And then for the 45 degrees, we're going to do 15 times 9.8. And it doesn't actually matter here. The signs basically just tell you direction. So for torque, I like to think of it, the direction as clockwise or counterclockwise. But if you wanted to, you could put it in. It's not going to matter because the cosine of negative 45 is going to be the same as cosine of 45. So I'm going to call that 104 Newton meters. So that is how I do this one. There's lots of explaining there, probably a little bit too much, but that's pretty much the general idea of how you do cross products and how torque is specifically a cross product between the radius as measured from the pivot point to the center of mass, and then F is the force that's causing the torque, in this case, due to gravity. So, hope that helped with this problem. See you in the next one.